Lymphocytes proliferate in response to antigen and peripheral lymphoid organs, generating effector cells and immunological memory. The large diversity of lymphocyte receptors means that there will usually be at least a few that can bind to any given foreign antigen. However, because each lymphocyte has a different receptor, the numbers of lymphocytes that can bind and respond to any given antigen is very small. To generate sufficient antigen-specific effector lymphocytes to fight an infection, a lymphocyte with an appropriate receptor specificity must be activated to proliferate before its progeny finally differentiate into effector cells. This clonal expansion is a feature common to all adaptive immune responses. As we have seen, lymphocyte activation and proliferation is initiated in the draining lymphoid tissues, where naive lymphocytes and activated antigen-presenting cells can come together. Antigens are thus presented to the naive recirculating lymphocytes as they migrate through the lymphoid tissue before returning to the bloodstream via the afferent lymph. On recognizing its specific antigen, a small lymphocyte stops migrating and enlarges. The chromatin in its nucleus becomes less dense. Nucleoli appear. The volume of both the nucleus and the cytoplasm increases, and new RNAs and proteins are synthesized. Within a few hours, the cell looks completely different and is known as a lymphoblast. The lymphoblasts now begin to divide, normally duplicating themselves 2 to 4 times every 24 hours for 3 to 5 days, so that one naive lymphocyte gives rise to a clone of around 1,000 daughter cells of identical specificity. These then differentiate into effector cells. In the case of B cells, the differentiated effector cells, the plasma cells, secrete antibody. In the case of the T cells, the effector cells are able to destroy infected cells or activate other cells of the immune system. These changes also affect the recirculation of antigen-specific lymphocytes. Changes in the cell adhesion molecules they express on their surface allow effector lymphocytes to migrate into sites of infection or stay in the lymphoid organs to activate B cells. After a naive lymphocyte has been activated, it takes 4 to 5 days before clonal expansion is complete and the lymphocytes have differentiated into effector cells. That is why adaptive immune responses occur only after a delay of several days. Effector cells have only a limited lifespan, and once antigen is removed, most of the antigen-specific cells generated by the clonal expansion of small lymphocytes undergo apoptosis. However, some persist after the antigen has been eliminated. These cells are known as memory cells and form the basis of immunological memory, which ensures a more rapid and effective response on a second encounter with a pathogen and thereby provides lasting protective immunity. The characteristics of immunological memory are readily observed by comparing the antibody response of an individual to a first or primary immunization with the response elicited in the same individual by a secondary or booster immunization with the same antigen. The secondary antibody response occurs after a shorter lag phase, achieves a markedly higher level, and produces antibodies of higher affinity or strength of binding for the antigen. The cellular basis of immunological memory is the clonal expansion and clonal differentiation of cells specific for the eliciting antigen, and it is therefore entirely antigen specific. And that's lymphocytes proliferate in response to antigen in peripheral lymphoid organs, generating effector cells and immunological memory. Have a great day.